Okay, we're going to do some more examples. I have to record these in 10-minute segments because to upload them to Blackboard, to upload them to YouTube, they need to be shorter videos. Okay, so let us look at another case of rationalizing the denominator. Suppose I have something like this. Now, the whole idea of rationalizing the denominator is so that we can get any radical expressions that aren't rational out of the denominator. And what we're going to do is we're going to multiply the top and the bottom of the fraction by something. But we're going to do it in such a way that it will get rid of the radicals. So what I'm going to use is called a conjugate. So if I have A plus B, its conjugate is A minus B. Okay? And usually we're just talking about radical expressions when we talk about conjugates or imaginary numbers. So the conjugate of radical 7 minus radical 2 would be radical 7 plus radical 2. And if I multiply the bottom of the fraction by this, I have to multiply the top. Okay, so now I'm just going to do distribution, just like you've done before in the past. My first times my first is radical 7 times a radical 7. My outers would be plus radical 2 times a radical 7. My inners would be minus radical 2 times a radical 7. And my last times my last would be negative radical 2 times a radical 2. Now what's in the numerator can't be simplified, so I'll just bring it down. The only way you can add radical expressions is if they have the same radicand and the same index. And we don't have that, so all we can do is just leave it like it is. So for the square root of 7 times the square root of 7, that would be the square root of 49, which is 7. This would be the square root of 14 minus the square root of 14. Well, those add out. And that's exactly why we want to use the conjugate pair. Because remember this? When you FOIL that out, you lose your middle term, the difference of two squares. Same rule. And then, of course, I have minus radical 2 times radical 2, which is 2. Continue to simplify. 10 radical 7 plus 10 radical 2 all over 5. Now, always, you have to check to make sure that whatever is in the fraction is simplified. And you can't cancel through addition, so I can't say this 5 goes into that 10 and just cancel that out. But what I can do is cancel factors. So I'm going to take a 5 out of the top. So I'm just factoring a 5 out. And on the bottom I have a 5. Now I'm not canceling through addition, I am canceling the factor. So my final solution is 2 radical 7 plus 2 radical 2. Okay? Now sometimes you will be asked to rationalize the numerator. So that means I don't want to get radical expressions out of the denominator of a fraction. It's okay to leave them there. What I don't want is a irrational or radical expression in the numerator. So again, I'm going to use conjugate pair, but I need to use the conjugate of the numerator. which would be the square root of 13 minus the square root of t. Okay. We're going to go ahead and distribute or FOIL. Radical 13 times radical 13 is going to be 13. The plus radical 13t minus radical 13t are going to go out. And then my last times my last, positive times a negative. Negative radical t times radical t is t. On the bottom, we just distribute. So my first times my first is going to give me 13 radical 13. My outers minus 13 radical t. My inners minus t radical 13. And my last times my last would be plus t radical t. Now none of these are like terms. None of these have anything that we can combine. We have 13 radical 13 minus t radical 13. But you can't combine them 13 minus t. There's no way to simplify it. So you just leave it as it is. And that is your final solution. Another simplification problem you might see is something like this, where we're taking the cube root of something where we don't have exponents here that are even multiples of 3. So I'm going to go ahead and break this thing apart. To the cube root of 81 times the cube root of m to the 4th times the cube root of m to the 7th. Well, the cube root of 81, does it have a perfect cube root? And the answer would be no, but I can rewrite it as 27 times 3. And in order to take the cube root of m to a certain power, I need m cubed. So I'm going to rewrite that as m cubed times m. And here, I need some multiple of 3, so I'm going to make that m to the 6th times m. So the cube root of 27 is 3, but I still got a 3 left under that cube root. The cube root of m cubed is m, and I've still got an m left under that cube root. And then the cube root of m to the 6th is m squared, and I'm left with a cube root of m. So all these are cube roots across here. So I'm going to go ahead and multiply the coefficient parts, you might want to call them. That's 3m cubed. And then I've got the cube root of 3 times m, and this should be an n, I apologize. I'm left with 3m n under the radical. Now, I'm trying to do this hurriedly, so I don't have time to do a lot of editing and go back and re-record right now. Eventually I will, so if I make a mistake and then see it later right now, please just give me a little leeway. Thank you.